Hi, in this video we're going to introduce long division of polynomials, really division of polynomials overall. We've studied adding, subtracting, and multiplying, so it leaves us with division as the one kind of thing that we can do with polynomials. Okay, there are two methods for dividing polynomials. One is called long division, okay, and the other one is called synthetic division, synthetic. And these two processes differ a little bit in that long division really is tougher, and synthetic division is a heck of a lot easier if you understand the process. The reason that we don't use synthetic division all the time, though, if it's easier, I mean, why not? Why wouldn't you use it all the time? Well, really, you can only use it when you're dividing, or you can use it a lot, okay? But you really should only use it when you're dividing by something that's like x plus a number or x minus a number. If we're dividing by one of these two things, so like when we divide by x minus 2, this is a good synthetic division problem. We're going to learn it the long division way, okay? But this is a good situation. When you divide by things like this, though, see, that's more complicated. Or if you divide, this is another way of writing a division problem, is over a fraction. If I'm dividing by something complicated, or maybe I'm dividing by 2x minus 3, or dividing by 3x plus 4, or something like that. If I have anything other than x plus or minus a number, it's probably going to be a long division problem. Now, that's tougher, but it's necessary because it works for all situations, no matter what we're dividing by. So it's a more generic case, in other words. It works no matter what we divide by. It's a little bit tougher, but it's necessary to know. The biggest thing to remember with either process, and this isn't going to make sense until we get to the examples, but go ahead and write it down. The biggest thing to remember with either process is that every power of x must have a place. It must be represented. And we're going to see that whenever we do this bottom problem down here. And what I'm referring to is the fact that if you can see that it says 3x to the fourth, 5x cubed. There's not an x squared. It strips down, it goes right down to the 4x, okay? It skips over the x squared. So we need to find a way to represent the x squareds in this problem. And we're going to see that in the third example whenever I go through that video. Now, real quick, before we actually jump into these problems, and I'm going to break this up into multiple videos, but before we do something like this, let's just review the process of long division, because you actually learned it back in like elementary school, like maybe 4th grade, 3rd grade, I don't know, somewhere around there, okay? Let's do a quick problem. Let's flip over a sheet. Do a quick problem dealing with numbers, okay? So let's say, for instance, how did I do a problem like 30 divided by 5? I would write it like this, right? So this is 30 divided by 5, or 30 divided by 5. Those are all ways of representing this problem, right? And I would say, so the big number, the thing on top, there's the numerator, goes inside. The denominator goes on the outside when I'm dividing by. And in this particular problem, I would have said, well, 5 does not go into 3 at all, so that's a 0. But 5 does go into 30, and it goes into it 6 times. So I would write it like this. 5 goes into 30 6 times, so I write the number up here. And then I would say 6 times 5 is equal to 30. And so I'd write a 30 down here. And I wouldn't add them. It's not 30 plus 30 down here. I would subtract this value, and that would give me 0. 5 doesn't go into 0. There's no remainder. 5 just goes into 30 6 times, and it goes into it evenly. So I would know that like this is like my remainder, right? Now sometimes if I'm dealing with bigger numbers, let's say what's 121 divided by 5? Now this one's getting a little more complicated, but the idea is the same. 5 doesn't go into 1, but 5 does go into 12. It goes into 12 2 times. So I would write a 2 up here over the 12. I would take 2 times 5, and I would multiply those together, and that gives me a 10. And I'm not adding 12 and 10 together, I'm subtracting the value from the bottom, and 12 minus 10 gives me 2. At that point in time, I drop the next value, the 1. I would say 5 goes into 21. It does go into 21. It goes into it 4 times. So I'd write a 4 up here. 4 times 5 is 20. So I would multiply the two values together, 4 times 5, and write the value at the bottom. And it's not 21 plus 20. It's 21 minus 20. And that gives me a 1. Now I'm out of values to drop, so I can't put anything else down here. So what, excuse me, what it really means then is that I have a remainder. I'm done. 5 is not bigger than this. 5 is bigger than what I have down here. So I can't go any farther with the process. And at first you learn to say, well, that means that it's 24 remainder 1. As you started to learn about fractions, you started to write it like this, 24 and 1/5. Why did you say 1? Because that's how many I have remaining. Why did you say 5th? Because that's what you were dividing by in the original problem, right? So that value got transferred over. So 24 and 1/5 is our way of saying that. And then we learned about decimals and things like that. But really, it's 24 and 1/5. So what we know now is that 121 divided by 5 is equivalent to 24 and 1/5. 24 plus 1/5, right? So that's going to be an important concept, the idea that we can just rewrite a fraction, okay? Because what we're going to do here in just a minute in these following videos is we're going to take this, like this fraction here, and we're going to rewrite it as something plus whatever the remainder is, similar to what we did right here. So hopefully that makes sense, the idea, the process. What we do is find out how many times is it going to here, put a number at the top, multiply the 2 down here, and we subtract. And then we repeat the process until we get down to a remainder, a number that's smaller than what we're dividing by. All right, so there's the first video. In the next video, I'll go ahead and we'll start working through these 3 examples. I see that as being probably 3 separate videos, to be perfectly honest. So we'll have 4 videos total for this series.